This is my sixth video lesson for Unit 15. In this lesson, we'll be analyzing functional groups. Go to page 22 in the class packet. Motivation: what is the relationship between function and structure? If you recall from last term, theme number 1, structure influences property. Learning target: at the end of the lesson, I'll be able to analyze different types of functional groups. Homework B number 6, which will be a Junipod based off this lesson. Functional groups are a specific group of atoms that give organic molecules distinct physical and chemical properties. In this molecule, this represents the hydrocarbon parent chain. The OH is an example of a functional group. R group stands for a group of atoms, for example, alkyl groups. Typically, R group would not stand for hydrogen. For example, this molecule can be written as ROH. The R stands for the hydrocarbon parent chain. Just to review, alkyl group is a constituent made from an alkane. Alkyl groups is formed by removing one hydrogen from the general formula, CnH2n plus 2. This general formula can be found on table Q. For example, methane is CH4. By removing one hydrogen, you'll get methyl, which is the alkyl group. The prefix meth means one carbon according to table P. Constituent ending ane is changed to pho, so methane becomes methyl. Here's an example of a molecule with alkyl groups. Here's the structural formula. Here's the line diagram. The alkyl groups are highlighted red. This is the methyl group. This is the ethyl group. Here are some examples of alkyl groups. Methyl is 1 carbon. Ethyl is 2 carbons. Propyl is 3 carbons. Butyl is 4 carbons, and so on. Table R shows a list of different classes of organic compounds. Think of it like families. Which functional group is present in each class of organic compound, their general formula, and example. On the Regents exam, you must be able to identify and match the functional group. Use the picture, the example, and the name to help you figure it out. Usually on the Regents exam, they'll give you a molecule or a chemical name, and you have to figure out what functional group is present or what type of organic compound it is. Think of it like a matching game. Now let's go over the different classes of organic compounds and their functional group. The first one on table R is halide. Halide refers to a group 17 element like fluorine, chlorine, iodine. Sometimes it's represented as an X. X is a halide. The functional group will be highlighted red for each class of organic compound in the molecule. Halides are treated as constituents, and the condensed formula for halides is Rx. The next class of organic compound is alcohol. The distinct feature of an alcohol is the OH group. The OH group is considered a hydroxy group. The condensed formula for alcohol is ROH. The next class of organic compound is ether. In ether, the oxygen is sandwiched between two R groups. R with apostrophe means R prime. This means that this R group can be different from this R group. In ethers, both R groups must be alkyl groups. Keep in mind this detail is not on table R. The atoms bonded to the oxygen must be carbons, and the condensed formula for ether is ROR prime. The next class of organic compounds is aldehyde. The aldehyde functional group is highlighted red. It's C double bond O with an H bonded to the carbon. The condensed formula for aldehyde is RCHO or R parentheses C double bond O H. Next is ketone. Ketones very similar to aldehyde. They both have C double bond O, but similar to ether, both R groups must be alkyl groups. The carbon of the C double bond O must be bonded to other carbon atoms. Keep in mind this detail is not on table R. The condensed formula for ketone is RCOR or RC double bond O R prime. The next class of organic compound is organic acid. The functional group of organic acid is C double bond O, and the hydroxy group is bonded to the carbon. Even though there's an OH group, this is not considered an alcohol. This is considered organic acid. Organic acids are different classes of compounds than alcohols. They have different properties. The condensed formula for organic acid is RCOOH or RC double bond O OH. As the name suggests, organic acid is considered an acid. It can lose a hydrogen ion. It can lose this hydrogen over here. The next class of organic compounds is ester. The ester functional group is highlighted red. The R' group must be an alkyl group. Keep in mind this detail is not on table R. So this oxygen must be bonding with a carbon. The condensed formula for ester is RCOOR' or RC"O"OR'. The next class of organic compounds is amine. Amines are nitrogen functional groups. The nitrogen can be bonded to hydrogen or R groups. Here are the condensed formulas for amine. The last class of organic compounds on table R is amide. The amide functional group is highlighted red. Keep in mind this is not considered amine. An amide functional group has a C"O" with a nitrogen group bonded to the carbon. Here are the condensed formula for amide. Again, you do not need to memorize all the classes of organic compounds. You just have to be able to identify them and match them. Most of this information on this table can be extracted from table R. To get the suffix ending, you have to go to table R, look at the chemical names of each of the examples. For halide, there is no suffix ending. This is because halides are also considered substituents. For alcohol, the ending will be OL. For ether, the ending will be ether. For aldehyde, the ending will be AL. For ketone, the ending will be ONE. Organic acid, also called carboxylic acid, the ending will be oic acid. Ester, the ending will be OH. Amine, the ending will be amine. Amide, the ending will be amide. Learning check number 1. Butanol and butanone and diethyl ether have different properties because the molecules of each compound differ in their what? Pause the video, resume as completed. By looking at the chemical name, the suffix is all different. Therefore, they have different types of functional groups, so the answer is choice 3. Learning check number 2. Given the formula for organic compound, this compound is classified as in what? Pause the video, resume as completed. So here's the functional group, the C"O" with an OH group bonded to a carbon. So the best answer is organic acid, choice 4. Learning check number 3. Which structural formula represents an aldehyde? Pause the video, resume as completed. So an aldehyde has a C"O" with a hydrogen bonded to the carbon. So the best answer is choice 3. Learning check number 4. The formula C5H11OH represents a what? Pause the video, resume as completed. Based off the condensed formula, the OH group represents an alcohol, so the answer is choice 4. Check of understanding number 1. Identify the similarities and differences between the following. We have an aldehyde, a ketone, organic acid, ester, and amide. All of these have a C"O", which is called a carbonyl group. The difference is what is bonding with the carbon of the carbonyl group. For aldehyde, it is a hydrogen bonded to the carbon. For ketone, it is an alkyl group bonded to the carbon. For organic acid, it is an OH group bonded to the carbon. For ester, it is an OR group bonded to the carbon. For amide, it is a nitrogen group bonded to the carbon. Check of understanding number 2. Which of the 3 molecules below will have similar functions and properties, and why? Notice that molecule A and B have the same functional group. They are both considered alcohol, while molecule C is an ether. So molecule A and B will have similar properties because they have the same functional groups. Learning check number 5. Which of these compounds has chemical properties most similar to the chemical properties of ethanoic acid? Pause the video, resume as completed. Ethanoic acid is considered an organic acid because of the suffix oic acid. Therefore, the best answer will be choice 1 because this molecule is also considered organic acid as well. Choice 2 is an alcohol. Choice 3 is an ester. Choice 4 is an ether. The term primary, secondary, tertiary are shorthand phrases to describe the following structure. Here are 3 examples: carbon in the alkane chain, alcohol, and amine. Primary means 1 R group. Secondary means 2 R groups. Tertiary means 3 R groups. Learning check number 6. Which compound is a primary alcohol? Pause the video. Resume as completed. The answer is choice 4. The carbon with the OH group only has one R group. That is why it's considered primary. For choice 1, the carbon with the OH group has two R groups. This is secondary. Choice 2 is organic acid, and choice 3 is an aldehyde. For practice number 1, use table R to figure out what functional group can be found in the following organic compounds. Try to do this yourself. Pause the video. Resume as completed. Here are the answers. In practice number 2, in each molecule, identify as many functional groups as possible. Pause the video. Resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Juniper homework.